Modulation and the need for modulation. We have seen the range of frequencies required for transmission of various kinds of signals, such as a speech signal, a music signal, video signal, etc. We have also seen the importance and restrictions imposed by the Earth's atmosphere in reflecting waves below certain frequencies. Due to these conditions, the signal waves, which are also called as the base waves, cannot be directly transmitted as it is. There are three basic reasons for choosing signals of higher frequencies. Size of antennas. Take an example of a speech signal. A speech which is of very low frequency, such as about 20 Hz, requires an antenna length of about 4,000 kilometers. Even in the upper range of audible frequencies, that is, at 20,000 Hz, the size of the antenna is about 4 kilometers. This is certainly neither possible nor desirable. Power emitted by the transmitter antennas. The power emitted by an antenna is also dependent on frequency. The power radiated by an antenna is inversely proportional to the square of the wavelength of signal being transmitted from it. Radiated power is directly proportional to 1 by lambda square. At higher frequency, since the corresponding wavelengths are small, the antennas can radiate signals at greater power. Therefore, more long-range and effective communication are needed to use higher frequency signals. Mixing up of signals. Nowadays, with increased dependence on communication network, each system should be able to handle data and signals coming from many sources simultaneously. For this to happen, we cannot allow the speech, voice or video signals of same frequencies to pass through same network simultaneously. There is a problem if very low frequencies are directly used for communication, because all the electronic appliances also emit electromagnetic radiation of very low frequencies. These unwanted electromagnetic waves mix with the data signal and add up to the noise which has to be filtered out at the receiver's end. Due to these reasons, we see that the signals that are to be transmitted have to be suitably modified such that they can be in high frequency. Modulation. The process of combining audio frequency signal with a high frequency signal is called as modulation. In general, the modulating signal, which is the actual signal containing the information to be transmitted, is given by the relation Ym is equal to Am sin omega mt plus phi. Here, Am is the amplitude of the modulating wave, omega m is the frequency of the modulating signal, phi is the phase constant. This modulating signal is combined with another wave of very high frequency called as the carrier signal. The carrier signal wave can generally be represented as Yc is equal to AC sin omega ct plus phi. Here, AC is the amplitude of the carrier wave, omega c is the frequency of the carrier signal. When the modulating signal is mixed with the high frequency carrier wave, there can be three modifications which take place in the carrier wave. Change in the frequency of the carrier wave. This type of modulation is called as the frequency modulation. Change in the amplitude of the carrier wave. This type of modulation is called as the amplitude modulation. Change in the phase of the carrier wave. This type of modulation is called as a phase modulation. Amplitude modulation. In this kind of modulation, the amplitude of the carrier signal changes with the change in the amplitude of the base signal. As we see here, this is the base signal of very low frequency which carries the information to be communicated. This is the unmodulated carrier wave of high frequency which can be superimposed to the base signal. When the base and the carrier waves are superimposed, the amplitude of the carrier wave changes in accordance to the amplitude of the base signal. This results in a modulated signal with an unchanged high frequency where the amplitude carries the required information to be communicated. Amplitude modulation is what is popularly known as the AM, which you hear in All India Radio Vibhida Bharati. Frequency modulation. In this kind of modulation, the frequency of the carrier signal changes with the change in the amplitude of the base signal. As we see here, this is the base signal of very low frequency which carries the information to be communicated. This is the unmodulated carrier wave of high frequency which can be superimposed to the base signal. When the base and the carrier waves are superimposed, the frequency of the carrier wave changes in accordance to the amplitude of the base signal. Here, the amplitude of the base signal is large and therefore the frequency of the carrier wave is also higher. In this region, the amplitude of the base signal is less and therefore the frequency of the carrier signal is also less. In this case, the amplitude of the carrier wave remains constant throughout. Frequency modulation is what is known as the FM. This is the famous abbreviation that you hear in all the FM channels such as the big 92.7 FM of the Radio Mirchi, 98.3 FM, etc. Similarly, in phase modulation, the phase of the carrier signal changes with the changing amplitude of the base signal. We have seen all the fundamentals of communication in this chapter. Communication system is a separate field of specialization. So the next time you look at a particular frequency range being mentioned in the TV or on the radio, you know the importance of the specific frequency. Some of you might become electronic and communications engineers. Then you will learn more about this fascinating and advanced technology involved in communication systems.